let's continue building our little VM. And as I recall, we started on kind of a stack last time. Yeah, we defined the stack, which I kind of forgot where we defined. We defined it here. Probably that needs to be its own file. So let's get that. Let's make a file that we call stack. It will be in main. And we put this here. And let's try to run it. And that didn't work because we need to import. And cannot send a next step. So there's a problem here for some reason. There's just a problem inside of stack. And let's disable Copilot. And I guess we need OS. And then we go back to VM. We look at line 23. Interesting. Is it possible just to return a... Well, I don't know. Let's do this then. And it seems to run fine. I don't remember exactly what the test was we wrote. Print the address on the top. And for some reason, anyway, let's add some debug printing. And specifically, I mean when we run here, before we do anything, we will print the current contents of the stack. So we're going to do something like when debug trace, and that's going to be a constant up here. Just that out as true. When that is true, then we say print the contents of the stack. Right. And the VM is this global thing. So we'll say for value in vm.stack.values. Let's first print something like this, and then we'll print let's just print the value. Let's just do like that for now. That should be fine. Then when we're done, we can do something like this. And let's try to run it, see what happens. Nothing happens because we're not running it. We can go and change that. Not there. I thought we had tried to run the VM at some point. But apparently not. We call this interpret. Interesting. So we want to interpret a chunk. Let's try to run it. and it prints a lot of crap, which is probably because we are, what is the stack capacity? It's 256, which admittedly is a bit too much. So what we want to do is we want to say if, can we do if value equals do you want to pass the iteral value to the forcing right point to get address semantics? Yes, and how do I do that? Okay, this makes more sense. So now we set up the stack, whatever, and we never put anything into the stack, it looks like. I think that's fine. But actually, let's do something. Can we do this? Is this a function? It's a function. Can we say push VM stack just to see that there's something there? There is indeed something there, and then let's do like a comma separated list like that, and we're gonna print a line. And that is again not really what we wanted, so now I need to get the I, so if I is greater than 0, then print a comma. That looks good. Let's try to push another value just to see, and that looks a lot better. But we had to manually push things into the stack, which really isn't what should happen. Really, when we're reading a constant, it should put that into the stack. So here we should say push that value into the stack. Then we can just delete those. Now if we run it, it somehow did not work. But it is printing out the value, just not pushing. That is really strange. So let me see what happens inside push. First we set the top to that, and then we increment it by 1. So let me add another one. Let me say basically something like this, but if I is greater than or equal to 10, then we break. Okay, so I feel like we lost something. No, we have it out here, value. So 3 is pushed, and then we indeed see that in the next iteration. Did I just do it wrong? Okay, great. So let me also go here and get rid of this. So we're interpreting some commands, which it might be helpful if we just disassemble that. So we're pushing 3 constants and then we're returning. So it's not really just put 3 constants on the stack. First there's nothing on the stack, then we get 3, then in the next iteration 3 is on the stack, then we get 15, so it seems to be working correctly. And for now we're gonna make the return statement actually pop it. So we're gonna say value equals pop from the stack, and then we're gonna print it. Just gonna print it. So it's kind of assumed. This is just for making it easy to debug. So if we run it, the final thing that should come out is this 23, the top value on the stack. So we can actually just go here and say don't do that, and also don't do that, and then we just see 23, last thing on the stack. Let's now go and add another operation, and I think it's in here, which is not gonna be very convenient. So I'm actually gonna get that out of here, and we're gonna make another one that we'll just call ops, I guess. It'll be main. Put that here. Let's see, it still runs. It does not run because we need to write all and then it runs. So we're gonna now have another operation, which is basically putting a minus in front of some number or a variable. And we then need to define how we execute that instruction. This is like basically a new command in our little assembly language. And we just add it here. And actually there's a case for not having a partial switch here. I don't know why I did that. Because now when I run it, it failed, and if I remove this, it should not fail. So it's actually quite nice to have that to make sure we don't forget anything. Don't know why it does that, that's a bit annoying. So first we need to get the top thing on the top of the stack, and then we simply need to put it back, but with an opposite sign. So what we can do here is we add a bunch of constants. Then it would be nice to add another operation to this chunk of operations that is negate. And I don't know if that will just work. It didn't work. What is this number? I forgot about that. Add underscore, add constant, add up. It's the line number, right? So it's like a fake line number. It's a bit inconvenient. So it certainly didn't like that. 56. That's very interesting. So now let's enable the debugging again. And okay. Something is really going wrong. What does the stack start out as? It does start out empty. Then we push 3 on it, we push 15 on it, push 23 on it. Then we should negate it, and then we should return. But something It's because I made a bug. No, I didn't. We shouldn't read a constant. We shouldn't read a constant. That's wrong. We should get it from the stack. Sorry about that. So we should pop from the stack. Now it works correctly. I'm gonna make another flag here that just lets me toggle both of these for now at the same time. So now it works correctly. Let's check what happens if we go here and run this. It just works. It's pretty nice. All right, let's now add some more interesting operations. And particularly we're going to add binary operations. So we're going to add, we're going to add subtract, we're going to add multiply, we're going to add divide. Now things should fail. Delete. And this one is, they're all going to do basically the same. So I would like to define some kind of function that applies an operator. So maybe we say apply plus. And let's do this. I don't know if it will work. Let's make this just without the T, so it's all 3 letters. So let's say apply. And what is that? It's a procedure, and it takes an operator, which is also a procedure, and it should take 2 values and return a value. And basically we want to say pop from the stack, and then a result is gonna be the operation applied to A and B, and then we push that back onto the stack. Let's see if that compiles. It did not compile because it does not like this. So I'm afraid there's no way around, no way to make this easier, because we don't have preprocessor, we don't have anything like that. So maybe we really need to do this. So it returns a value, and it's just A plus B. And at this point there's almost okay, but that works. That works. Let me delete this. And what is it complaining about? Undeclared name. Let's write all. And it seems to work. So now we can actually start to do a calculation. For example, let's multiply 3 and 5. It really doesn't matter. So we put them on the stack, then we multiply them, and then we look at what the result is. So we run that, and then we get 15. Now an important point is that the first thing you put on the stack is the first argument. So if we say subtract, it's going to be -2 because we say 3 minus 2. If you want it the other way around, you need to do this, then it's 5 minus 3. But now we have actually a basic calculator. And we can do things like 3 plus 2 minus 15. Let's try to do that. So first we multiply those together. Then we add 1. And we can just add it now. Then we add a 15. And then we subtract that. And is that correct? It should be 6, 7, minus 8. And it is indeed -8. And great. Now we can do arithmetic. And it even works with the disassembly. So that's nice. So I think that's going to do it for this video, and I will see you in the next one.